The Saharan silver ant. There's a number in every biology textbook. The temperature at which animal protein denatures and starts to cook. This is an animal that treats that number like a suggestion. You know the feeling of stepping onto summer asphalt barefoot and jumping back immediately? Triple it. The Saharan silver ant, Cataglyphis bombycina, walks out into that deliberately, at noon, every day. Because noon is actually the safest time to move. When surface temperatures hit 60 to 70 degrees Celsius, somewhere between 140 and 158 degrees Fahrenheit, every predator that would eat this ant has retreated to shade. The ant has about 6 minutes before its own tissues give out, so it sprints, covering 108 body lengths per second, roughly equivalent to a human running 800 kilometers per hour. What makes this possible is its coat, triangular silver hairs that work as tiny prisms, reflecting incoming light and radiating heat outward. 158 degrees Fahrenheit, hotter than a rare steak pulled from the grill, hotter than the safe temperature for cooked pork. Every extra second spent on that sand is a second closer to cooking from the inside. Evolution found the sun's upper limit and built an ant that shrugs at it. The Antarctic Icefish. Every vertebrate on this planet runs on red blood. Every mammal, every bird, every reptile, every other fish. Imagine cutting your finger and watching something the color of milk come out. By any normal measure, that animal should be dead. The Antarctic Icefish family, Channictheidae, is the only known group of vertebrates without functional hemoglobin or red blood cells as adults. They live in water between -1.8 and 2 degrees Celsius in the Southern Ocean, where the cold naturally holds near-peak dissolved oxygen. Roughly 8.5 million years ago, a transposable element deletion wiped out their hemoglobin gene cluster, and the environment never punished the loss. To compensate, these fish evolved enormous hearts, huge blood vessels, and scaleless skin that absorbs oxygen directly. Despite looking anemic, they're not broken. They're calibrated. Antarctic water is a free oxygen delivery service, and the icefish outsourced its circulatory system to the ocean. The icefish abandoned hemoglobin 2 million years before our own genus branched off. The only vertebrate on Earth with see-through blood. No other spine has managed it, and 8.5 million years of evolution haven't produced a sequel. The tardigrade. There's probably one on your windowsill right now. One in the moss outside your building, one in the gutter. If an asteroid hit tomorrow, the mammals would go, the forests would go, and these 8-legged microanimals would just keep going. The textbook had another line. Space would sterilize any animal instantly. Then, in 2007, a satellite came home with passengers. The European Space Agency strapped tardigrades to the outside of a spacecraft, left them in open vacuum and unfiltered cosmic radiation for 10 days, brought them home, added water, and most of them walked off. Picture something between a roly-poly bug and a very confident grain of rice. They survive by entering cryptobiosis, losing nearly all body water and collapsing into a desiccated state where metabolism drops to near zero. A human dies at about 5 grays of radiation. A tardigrade absorbs 1,000 grays and recovers. 200 times a lethal dose, absorbed by something smaller than a grain of salt. They're not immortal though. They just pause so completely that a 3-month life can be spread across decades. They have been boiled, frozen, irradiated, crushed, and shot into space. They keep coming back. And they're, right now, sitting on whatever you're sitting on. The Greenland Shark. If you met one in a bar and asked for ID, it could tell you stories about watching Napoleon lose. Not in the poetic sense, in the paperwork sense. The Greenland shark, Somniosus microcephalus, lives in the North Atlantic and Arctic in water between -1 and 10 degrees Celsius, down to 2,200 meters. It doesn't reach sexual maturity until around 150 years of age. Scientists carbon dated a 16-foot female caught in 2016 and got back a result that made them recheck the instrument, roughly 400 years old. Possibly the longest-lived vertebrate on Earth. Born around the time Galileo was still calibrating his first telescope, older than the United States. The biology behind it's almost boring. Cold water means slower metabolism, which means slower cell damage, slower DNA degradation, slower everything. Urea and trimethylamine oxide in the tissues prevent freezing, while also protecting against cellular stress. Evolution ran the move less, eat less, live forever experiment and pushed the slider all the way. At the end of 400 years, every extreme we call hostile is just an address no one else wanted. The Rüppell's Vulture. The plane on your last flight was probably cruising between 10,000 and 12,000 meters. A human dropped there without a pressure suit has about 15 seconds of useful consciousness. This bird lives up there. Rüppell's vulture, Gyps rüppelli, holds the confirmed altitude record for any bird ever measured, 11,300 meters, logged in an airliner's flight record over Ivory Coast on November 29, 1973, when one of these birds collided with the jet at cruising altitude. The American Museum of Natural History identified the feathers from the engine. The textbook said birds hit an oxygen ceiling at 7 kilometers. This one flew into a jet engine at 11. What makes it work is a single amino acid change in the alpha-D hemoglobin chain, which dramatically improves oxygen binding at low atmospheric pressure. One protein, one edit. The vulture cliché is patient, lazy, circling something already dying. This species flies higher than any other bird ever measured, above Everest, above the operational ceiling of most helicopters. Populations have collapsed roughly 90% since the 1970s, largely due to diclofenac, a livestock painkiller. A bird carrying modified hemoglobin hit a jet carrying 400 people. The jet landed. If this list is making your biology textbook feel a little embarrassed, I post new animal content here regularly. Subscribing helps a lot. Thanks. The devil worm. There's rock beneath you right now. More rock beneath that. 2¼ miles straight down, in fractured stone under South African gold mining country, a living animal is eating bacteria out of 12,000-year-old groundwater, and it's fine. The devil worm, Halocephalobus mephisto, was discovered in 2011 at depths between 0.9 and 3.6 kilometers underground. Before that, biology had a rule. Multicellular life doesn't go past a few hundred meters below the surface. The devil worm found that rule funny. It thrives at 37 degrees Celsius, past 10 Empire State Buildings stacked end to end, past 30 Statues of Liberty, in water older than the invention of writing. It gets there via re-engineered enzymes and respiration pathways, essentially a nematode that rebuilt its power plant to run on chemical scraps in the dark. There's a slow chemistry running below the crust that has been going since there's been a planet. Nobody knows what came first down there, the devil worm or the bacteria it eats. Either way, neither one has seen the sun in longer than humans have existed. The Sleeping Chironomid. Your body is roughly 60% water. Lose 20% of it and you're dead. This larva loses 97% and calls it a nap. The sleeping chironomid, Polypetalum vanderplanki, is a midge larva from semi-arid Africa that lives in shallow rock pools. When the pools dry out, it replaces nearly all body water with trehalose, a sugar that forms a glassy matrix holding cell structures intact at zero metabolic cost. Dried to about 3% water, the moisture content of a cracker, and it stays that way for longer than most marriages last. In that state, it tolerates near absolute zero, 106 degrees Celsius, hard vacuum, and radiation doses that would finish most things still active. In 1962, a researcher collected dried larvae from a Nigerian rock pool. A lab rehydrated them 17 years later. Some larvae woke up and kept growing. The textbook was clear on this one. A multicellular animal can't lose nearly all its water and come back. The larva didn't read the textbook. The common assumption is that complete desiccation survival is a microbe trick, bacteria and single-celled organisms. Polypetalum vanderplanki is a full-blown insect larva doing it, the only insect known to survive being freeze-dried, boiled, and soaked in vacuum for a day, then rehydrated, like instant noodles but alive. The Yeti Crab. 2 kilometers down in the pitch-black Pacific, volcanic chimneys shoot superheated water into the ocean at temperatures that would melt solder. Around those chimneys, there's farming. The Yeti crab, Kiwa hirsuta, first described in 2005 near hydrothermal vents off Easter Island, is blind, with pale, fur-like bristles covering its claws. Those bristles host sulfur-oxidizing bacteria, which the crab cultivates by waving its arms over vent fluid and then scraping the bacteria off with its mouth parts to eat. Researchers have filmed these crabs at densities of around 700 per square meter of vent field. 700 crabs on a doormat, all waving their fuzzy arms at a volcanic chimney, tending their bacterial gardens. At what point is the difference between a crab and a pasture a philosophical question? No sunlight reaches that ecosystem. The whole food web runs on chemosynthesis, and Yeti crabs evolved specifically to exploit it. A blind crab at the edge of a volcanic chimney, farming the one food source that will never run out. That's not surviving. That's a business plan. When the food won't come to you, grow a farm on your own arms. Biology, it turns out, is just real estate with enzymes. The Mariana Snailfish. At 1 kilometer down, the pressure crumples a sealed soda can. The snailfish lives 8 kilometers deeper than that. Whatever shape you're imagining it having, the pressure at its depth has already addressed the situation. In August 2022, a baited camera dropped into the Izu Ogasawara Trench filmed a juvenile snailfish at 8,336 meters, the deepest bony fish ever recorded, nibbling at bait. Biologists had quietly modeled a theoretical ceiling around 8,200 meters, past which protein chemistry should fail. The textbook set a ceiling at 8,200 meters for bony fish. This one swam 136 meters past the ceiling and bit the bait. What makes this work is trimethylamine N-oxide, a chemical that counteracts pressure-induced protein misfolding, produced in escalating amounts the deeper the fish goes. Its body is gelatinous rather than rigid, no scaffold for the pressure to crush. At 800 atmospheres, roughly 1,600 elephants pressing on every square inch of body, and it was nibbling bait like a goldfish at the surface. Somewhere below this fish, right now, something is looking up at it the way it looks up at us, too close to the surface. The Pompeii Worm. On land, the hottest environment any vertebrate reliably survives is around 50 degrees Celsius. This polychaete worm sticks its tail into 80-degree water and stays. The Pompeii worm, Alvinella pompeiana, lives in tubes on black smoker chimneys around 2,500 meters deep in the Pacific. Its head sits in water at about 22 degrees Celsius. Its tail stays in water at around 80 degrees. A 58-degree gradient across a body shorter than your hand, every moment of its life. Under a microscope, it doesn't look like a worm. It looks like something between a dragon and a mop, with a shaggy coat of symbiotic bacteria covering its back, bacteria it farms for food and which double as thermal insulation. The popular claim that it lives in 176-degree Fahrenheit water full-time is overstated. Its thermal optimum is closer to 42 degrees Celsius. Sustained exposure above 55 degrees is lethal. The tail visits the high end briefly. What earns it the record is cumulative tolerance. Its proteins, collagen, and symbionts all holding up at temperatures that would ruin almost anything else. Its collagen stays stable at 113 degrees Fahrenheit, the most heat-tolerant connective tissue ever measured in an animal body. Loricifera. Every animal on this list broke a rule. Heat, cold, depth, altitude, dryness, pressure, but there's one rule underneath all of those. The rule that never gets questioned, written on page 1 of every biology textbook. Animals breathe oxygen. Loricifera ignored it. In 2010, researchers pulled sediment cores from the La Adelante Basin, a hypersaline anoxic depression 3,500 meters deep in the Mediterranean. What they found weren't fossils. They were living populations of tiny armored animals, roughly 0.1 to 0.5 millimeters long, completing their entire life cycles in permanently oxygen-free water. Born without oxygen, reproducing without oxygen, dying without oxygen, never having encountered a single molecule. Their cells contain organelles resembling hydrogenosomes found in single-celled organisms that produce ATP anaerobically by fermenting pyruvate instead of running standard mitochondria. The paper describing them rewrote things, not revised a section. The biology community had to reconsider what they thought they knew about the minimum requirements for animal life. A 2021 re-examination raised fresh questions about whether true mitochondria might still be present somewhere in their cells, so the science is still actively contested. Either way, they live and breed where textbooks say animals can't. Every biology textbook opens with the same sentence: life requires oxygen. Loricifera read that sentence and laughed. Or would if it needed to breathe to do it. Every entry on this list broke one page of the textbook. Loricifera burned the book. If this one stuck with you, there's a whole channel of animals that make evolution look improvised. Thanks for watching.